Hello, boys and girls. Today we are looking at greatest common factor, which is lesson 4-2 out of our textbook. And our learning target for today says, I can find the greatest common factor of two or more numbers. All right, so here we see our icons. We have the vocabulary icon, which tells us there are some words here that we need to know. One of them is factor, and we know that factor are those numbers that we are multiplying together. And we also have multiple. So this is like the multiples of 2 are 0, 2, 4, and 6. So this is the numbers that 2 are going into. Okay? Now our little think icon here tells us to stop and think about this image that's shown and see how it'll relate to our lesson. So we have this Venn diagram here, and in the Venn diagram it is showing us the prime factors of 12 and 18, and in the middle here you see the numbers that are overlapping that are both prime numbers in 12 and in 18, so which are 2 and 3, and that goes along with our greatest common factor, which is what we are talking about today. Our greatest common factor, just like the name says, they are the common factors between two or more numbers, and it is the biggest number between them. There are a couple different methods that we can use here to find the greatest common factor in a set of numbers. The first method that we are going to look at is to list the factors. So we start with our 18, because we're looking at 18 and 48, and we list the factors of that. Well, we know 1 can go into 18, and it goes in there 18 times. We know 2 goes into 18, and it goes in there 9 times. We know 3 goes in there, and it goes in there 6 times. 4 does not. 5 does not. We have 6. 7 does not. 8 does not. And we already have the 9, so now we are at the halfway point. So there are all of our factors for 18. Now we're going to list the factors of 48. All right. So now our factors for 48, I know that 1 goes in there 48 times. Next we have 2, which goes in there 24 times. Then we have 3, which goes in there 16 times. 4 goes in there 12 times. We're running out of room. But 6 goes in there 8 times. I have to write it below. Okay. 9 cannot, 10 cannot, 11 cannot, and now 12 we already have, so we're back to numbers we already have. Okay, so I'm listing them in order so that it is easier to see. Now, greatest common factor, just like the name says, we are looking for the largest number that goes both into 18 and 48. And after listing the factors here, we see that our greatest common factor for this is going to be 6. Okay, so the greatest common factor, or the GCF, is going to be 6. Okay. Another method that we can use here is with prime factorization. So like what we practiced yesterday, doing those factor trees. So I'm going to take 8 and split it up into its factors. So 2 and 9, 2 is a prime number. 3, 9 splits up into 3 and 3. Circle those because those are prime. So we have prime factorization of 18 gives us 2 times 3 times 3. Now for today, for this, I'm going to leave them written out like this. I am not going to write them as exponents or anything like that. I want to make sure that we know that those are separated. Okay, next, prime factorization of 48. I'm going to split this up into 2 and 24. Okay. 2 is prime. again, 2 and 12. I'm going to split this into 3 and 4, and then 2 and 2. Okay, so now let's write out our prime factorization of 48, which is 2 times 2 times 3 times 2 times 2. Okay? Now for this, we are looking for numbers that are in both 18 and 48. We're looking for pairs of numbers. So here we have a pair of 2's. Okay, there's a 2 both in the 18 and the 48. And then we also have a pair of 3's here. Now we have one more 3 in the 18, but no more in the 48. And then same thing the other way. We have a couple more 2's in the 48, but no more in the 18. We are just looking for those pairs. Okay? Now what we are going to do is we're going to take our pair of 2's, we're just taking one of them, and our pair of 3's, and we're multiplying those together. Now we do not take each of the 2's from the pair and each of the pairs from the 3. That's where it might get a little confusing. We're just taking the one number, so the 2 and the 3, multiply them together to get 6. So then that tells us that, again, our greatest common factor, or our GCF, for 18 and 48 is 6. So if you look, whichever way we do it, whether it's listing the factors or using prime factorization, either way we will get the same answer. Okay, we have a couple example problems for you to try down here. Pause and then continue watching to see if you've got it correct. For 8 and 10, I'm going to list the factors. I'm going to zoom in here. Our factors of 8. Well, 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 goes into 8. Our factors of 10, again, 1, 2, 3 does not, 4 does not, 5 does, 6 does not, 7 does not, 8 does not, 9, but 10 does. So for this one, our greatest common factor, we see 2 is in both of them, nothing bigger. So our greatest common factor equals 2. Next one here, 6 and 12. For this one, I'll do a factor tree. 6 can be broken up into 2 and 3, and those are both prime. So for 6, we have 2 times 3. Now for 12, I can split it up into 2 and 6, and then 2 and 3. Okay. Both of those are prime. So now for 12, our prime factorization would be 2 times 2 times 3. Look for those pairs in both of them. There's a 2 here in both of them, and a 3 here in both of them. So we would take one of those 2's, multiply it by one of the 3's to get 6. So our greatest common factor equals 6. Okay, we can do a quick check of the other way as well, listing the factors of 6. 1, 2, 3, 6 for 12. 1, 2, 3, 4, 6, and 12. So our greatest common factor, again, would be 6. Whichever way you do it, you will get this, it gives you the same answer. One more here, 10 and 17. I'm going to do this one probably both ways again. Let's start with listing the factors. For 10, we found 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 17, 1 and 17. We know 17 is prime. Only 1 in itself go into there. Now, for this one, our greatest common factor, the only number that goes into both 10 and 17 is 1. So that means our GCF equals 1. And if we do a factor tree for this one, 2 and 5, both of which are prime. 2 times 5. Okay. And then 17. Well, 1, 17, both of those are prime. 1 times 17. Notice they don't have any pairs, so our greatest common factor, again, equals 1. Okay. All right, here we are looking at finding the greatest common factor of 3 numbers. Now we do this the same way, either doing the factor tree or listing out the factors. So I'm going to do a factor tree for this one for 12, 34, and 60. So I'm going to start with 12. Doing my factor tree. 2 and 6. 2 and 3. So for 12, we have 2 times 2 times 3. Now for 34, we can break that up into 2 and 17. Both of those are prime. 34 are 2 times 17. And then our last one, 60, I'm going to split that up into 2 and 30, 2 and 15, and 3 and 5. So for 60, we have 2 times 2 times 3 times 5. Now we look, we have 2 between all 3 of them here. And we have a 2 and a 3 in the 12. We only have a 17 left in the 34, and then 2, 3, and 5. So that is our only pair. So for this one, the greatest common factor between these 3 numbers equals 2. Try these next 2 on your own and then come back and check your answers after you have done them. Alright, our first one here is 30. This time I'm going to list out the factors. Let's see. 1 goes into 30 30 times. We've got 2 and 15, 3 and 10. 4 does not. 5 goes in there 6 times. 7, 8, 9, 10. Now we're back to the numbers we already did. So there are our factors for that one. 45, 1 and 45. 2 cannot go in there because it's not an even number. 3 goes in there 15 times. 4 does not. 5 goes in there 9 times. 6 does not. 7 does not. 8 does not. 9. Now we're back to the top. So there's our factors for that one. And the last one, 75. Okay, for 75, 1 goes in there 75 times. 2 does not, because again it's not even. 3 goes in there 25 times. And 5 goes in there 15 times. 6 does not, 7 does not, 8 does not, 9, 10, 11, 12, 13, 14, and now we are back to 15, which we already have. Now we look between the 3 to see what is our largest number. I see we have 15 is our largest between all 3, so our greatest common factor equals 15. Okay, next one here, 42, 70, and 84. I'm going to do factor trees for this one, so 42. Okay, break this up into numbers here. 42, I'm going to break it up into 2 and 21. Then 3 and 7, those are both prime. Okay, I'm going to write this way at the bottom here. So for 42, we have 2 times 3 times 7. Next one, 70, 2 and 35. Then I'm going to break this up into 5 and 7, both of those being prime. 2 times 5 times 7, and then 84. Okay, that breaks up into 2 and 42. 2 is prime. 2 and 21. 3 and 7. So for 84, we've got 2 times 2 times 3 times 7. Now we look through all three of these to find our sets that each three numbers carries. Well, I see that each have a 2 here. 42 has a 3, but 70 does not and 84 does not. So since it's not in all three of them, that one does not work. I see that they all have a 7. Okay. 70 has a 5, but neither of the other ones do, and 84 has another 2, but neither of them do. So now, just like when we had two numbers, we only take one number from each of them that we circled. So from all the 2's that we circled, we only take one of them. And from all of the 7's that we circled, we only take one of them. And we multiply them together. 2 times 7 is 14. So our GCF for 42, 70, and 84 equals 14. All right, so go ahead, take your NICU for this lesson, the 4-2 NICU. Bring your notes tomorrow to show me and any questions that you might have. Don't forget, if you're still confused, you can always go back and re-watch this video. You can also read the examples in the book, and you can watch, there's personal tutor videos in the online textbook resources that you could go and watch.